Thanks everyone for coming. I really appreciate you spending some time with us today. So at Coiled, we focus on making it easy to run your code in the cloud. We have a variety of APIs to accommodate that, depending on your particular use case. And today I'm excited to talk about our Coiled Notebooks feature. Coiled Notebooks make it easy to run your Jupyter notebooks in the cloud. We're all familiar with how to run Jupyter locally on our, whether it's a local workstation or a laptop. You, for example, fire up a terminal, type in JupyterLab, and you're good to go. You've got a JupyterLab session running, all of your local notebooks, and you can run them on your machine. To do the same thing in the cloud with Coiled, you would, instead of typing JupyterLab, type Coiled Notebook Start, and that will spin up a JupyterLab session running for you on the cloud. And that's all fine and dandy, but you might be asking yourself, why would I want to do this in the first place? Why do I need to run Jupyter in the cloud and not my local machine? And we see we see a few common use cases. The first is when you're working with data intensive applications that are analyzing cloud hosted data. So if your notebook is accessing cloud data, if you can move the, like for example, if the data is in some S3 bucket somewhere, if you can move your JupyterLab session where the actual computations are running to also be in the cloud located right alongside the data, you significantly cut down on data transfers. So this reduces costs. And it also, you see some serious performance improvements that we'll see in an example in just a moment. You no longer have to transfer data from, for example, AWS to your laptop and back. That has some serious performance implications. The other common use case we see is when you move your JupyterLab session to the cloud, you're kind of untethered from your local machine, the hardware on your local machine. This means you can really access any hardware that's available on your cloud provider. So things like accelerated hardware, like GPUs, or sometimes you just simply need a bigger machine. Like my laptop has 16 gigabytes of memory. If I want to do something that requires 100 gigabytes of memory, I'm just kind of out of luck. But if I can easily transition to the cloud, I can request a big machine and it's all good. And we're excited about Coiled Notebooks because it helps accommodate these common use cases with a simple, familiar API. Sort of in contrast with some other cloud notebook service providers, things like AWS SageMaker, Google Colab, Coiled Notebooks are a really lightweight solution. So other services, often there's additional infrastructure you need to manage, or they're just in general a little more heavyweight than Python developers, in particular PyData developers, are sort of accustomed to and sort of like to interact with. So Coiled Notebooks are really lightweight touch. So that being said, let's go see some of this stuff in action. So I'm gonna pull up a terminal here. Hopefully everyone can see my terminal. So I'm sitting here on my laptop. I'm in a repo that has a bunch of notebooks that I would like to run on the cloud. So to do that, I'm going to type Coiled Notebook Start. And that's sort of the bare minimum. If I hit enter now, that will spin up a JupyterLab session for me in the cloud. There are a couple other optional flags here I'm going to explore as well. So the first is this sync option that will automatically have Coiled sync all my files that are here. All those notebooks that I showed you will automatically get pushed up to the cloud VM where Jupyter is running, and that will be synced back locally. And we'll see an example of that in just a moment. So let's make sure I have all my files easily accessible on the cloud. If you're looking at data that's in a particular region, you can use the keyword argument, the region keyword or the region command option here to have your Jupyter session provisioned in that same cloud region right alongside your data. For the first example I'm going to show you, I don't need a fancy machine type, but this is how you would provision whatever machine you would like. So I can say, hey, I'm on AWS. Please make sure that this Jupyter session is running on an M6i 2x large instance, for example. All right, so I will go ahead and hit enter, and we start spinning up a notebook. So the first thing that happened here was Coiled Notebooks, like all the other Coiled APIs, have automatic software synchronization. So I noticed I didn't have to like really think much about my software environment here, or I certainly didn't have to build a Docker image. So what Coiled does is it scrapes my local Python environment. It finds all the pip installed packages, all the conda installed packages, any like editable installs, any wheels I may have laying around. If I've done like a pip install -e, for example, it finds all that, packages it up, and ships it off to the VM that we're spinning up here. So this is nice because, again, I didn't really have to think about that step. We do support Docker images. We'll see that in another example. If you happen to have some Docker images laying around, or that's part of your normal workflow. But by default, you sort of get this automatic package synchronization, which is nice. So we can see our VM has booted up. I'll go ahead and click this link here to get some more insight into what's happening. So we're now in the Coiled app, and we can see, the first thing I see is this progress bar here. We see our VM was queued for a bit, starting up, the instance was running. Now we're downloading all the software that I had installed locally, like JupyterLab, well, Python, all that good stuff is now getting downloaded onto the VM instance. I asked for this to be provisioned in US East 1. We see that's happening. I asked for a specific instance type, M6i 2x large. We can see that instance is being spun up here. I can also go see the software environment that's being installed. So these were all the packages I had installed. Locally, I just have a Conda environment that I've installed to in over the time. And you can see all the packages here that are being installed. So spinning up this notebook takes about 1 to 2 minutes typically. And just like JupyterLab, when you run locally, whenever the notebook is ready, it'll automatically open up for us in our browser. That was timed perfectly. Here's our JupyterLab session. So this I'll make it a little bit bigger so we can see. Yeah, these are all the files here that I had locally on my laptop. And this JupyterLab session is exactly like what I would be running locally. It's just running in the cloud. It's not in localhost. So the first thing I want to show is that automatic file syncing feature. So I'm going to go ahead and open up a new text file and say, hello from the cloud. I'll save that to hello.txt for lack of more creativity. And we can see that file was created here. Again, this is in the cloud VM that's running on AWS. I can then go back to my laptop and see that hello file was created here locally. It was synced back to my machine. And that syncing is actually two-way. I can actually go into this file on my laptop and say, hello from my laptop, and save that file. And now when I go back to my JupyterLab session in the cloud and open up that file, I can see I now have the changes I made locally were propagated up to the machine on the cloud. So running Jupyter with Coiled notebooks really does look and feel a lot like you're working on your local machine. So the experience should be really similar to what most folks are used to. Okay, the first example I want to show here is, I'm going to go ahead and just run these cells real quick. And now we can sort of look into what they're doing. So this example processes lots of Parquet files on S3. So first we use S3FS to get paths for all the files. This is New York taxi data. It lives in US East 1 on AWS. That was why I said region equals US East 1 when spinning up this notebook server. So we get all the data files for the year 2022. And there are 12 of them. There's one for each month. So we can see January, February, all the way down through December. So now that I have these file paths, I want to do some processing with this data. So we define a process function here that uses pandas to read in a single file, does some filtering. Again, this is taxi data. So in this particular case, we're filtering out to only look at data where there was a tip for the taxi ride. We then take that filtered or processed data set and then use pandas again to upload that back to S3 to a different bucket. Then down here, we take that processing function and just map it across those 12 files and print out, hey, I'm done with the file as we're done with them. And we ran, and we can see that took a minute to run. You can see process January, February, March, all the way down through December. And that took about a minute. So I can run this exact same notebook on my laptop and it will work perfectly fine. I will get the exact same result. In fact, I did that right before the webinar started. I ran the same exact notebook, but on my laptop and saved all the outputs. So we can see the output is the same, the results are all the same, but it took 13 minutes and 15 seconds. So comparing that with when running on the cloud, it took a minute. So over an order of magnitude of increase in performance. And this has everything to do with that reducing data transfers. And this was just for 12 files. You can imagine running not 12 files, but 100 files or 1,000 files or 10,000 files. This performance improvement really adds up over time. So hopefully this gives a sort of a sense for what it's like to work with Coiled notebooks and some of the benefits to that easy data proximate computing. The next example I want to show, I have 2 more examples, and to avoid that 1 to 2 minute startup time for the notebooks, I've actually already launched the notebooks. The next example was launched with this command here. So we're running this on a G5X large instance on AWS that has a GPU on it, that instance type. And then I just wanted to show off, we also do support Docker images, should that be important for your use case. So here I'm using some GPU-enabled Docker image. And yeah, I've also specified the region as well. So let's go ahead and look. So that instance, that Jupyter instance is running here. And let's go ahead and run this code. So for those of you who aren't familiar with PyTorch, totally fine. Just know that we're here using PyTorch to define a machine learning model. It's a neural network. We have some data that we're reading in to train our model with. And then for those who are familiar with PyTorch, this code should look familiar. If you're not, the important thing to know is that it requires a GPU to actually run. So neural networks like PyTorch models or other models as well can often be accelerated significantly whenever they have more advanced hardware like GPUs. So go ahead and run that cell. And then here we're actually going to train this model, not once, but 5 different times. So here we're using Optuna, which is a popular hyperparameter optimization library. So we're actually going to train the model 5 different times, sweeping across different parameters so that we can find the set of parameters that results in the best model predictions. So here we're going through, we've trained 4 of the 5 models, and there's the 5th model. That took about 25 seconds, and then we can print out some of the results for that model. So here are some of the hyperparameters that were found to be optimal. And again, the important thing here is that I just took some code and ran it on the GPU pretty easily. Speaking from experience, I'm personally very excited about this. I'm joining this webinar on a MacBook that doesn't have a GPU attached to it. So there's been many instances when I've wanted to run, whether it's GPU accelerated PyTorch or XGBoost or anything in the Rapids stack, the Rapids ecosystem. I just haven't been able to. And so I personally am very excited about Coiled notebooks because it enables me to do that pretty straightforwardly. Okay, the last example I want to run is this one. So I used Coiled Notebook Start to launch a notebook server on this instance. It's an M6i 16x large in a specific region. We're going to look at some data that lives in US West 2. So I want my notebook to be running there. For those of you who don't, actually, I'll go ahead and get this started. For those of you who don't know or have your AWS instance types memorized, that is okay. The instance this is running on has 256 gigabytes of RAM, and it has 64 cores, I think. So this is a much beefier machine than I have locally. Again, my laptop has, I think, 16 gigabytes of memory. So here we're analyzing, again, some New York taxi data. This time it lives in US East 2. And we're using DuckDB to analyze that. DuckDB is a popular library for working with tabular data, letting you do SQL queries and things like that. So the first thing we do here is create a DuckDB connection. And then because we're accessing data on S3, we need to set a few S3 specific bits. We then take that connection and we load our data into a table. So we have a create table line here where we are reading in a bunch of Parquet files in S3, and we're reading in the whole data set. Before we were just reading in the year 2022, and here we're reading in the entire thing. And this is, I think, like 150 gigabytes in size. So I definitely can't run this. I can't execute this cell if I was running this locally on my laptop. And then now that we have our data loaded, we then perform some query on it. In this particular case, we're doing a group by aggregation. We're looking at each of the service providers for the taxi data. So like Uber, Lyft, those are sort of the various service providers. And we're looking at the average tip for each of the service providers. And down here, we're actually running that query, and you can see the little progress bar happening here. So if I go back to Coiled, the Coiled app, and look at this notebook server that's running here, I get some insight into the metrics for this computation. So here we can see I'm, reading in. At this point, I've already passed. I'm reading in, 21.6 gigabytes. At this point, I've already passed what I can do on my laptop. And then we keep going. We're looking at the memory used. We're at 124. The other nice thing is DuckDB actually is able to better utilize all the cores that are available on this machine. So you can see the CPU usage is over 1,000%, which is also more than I could do on my laptop. So if I go back to the example, we see it's successfully run. It took 2.5 minutes. I happen to know that these little identification codes correspond to the different service providers. I happen to know this one is Lyft. So the average tip is about 20%. This one is Uber. The average tip is about 15%. So maybe that's expected. Maybe it's not. So yeah, this example I definitely could not have run on my laptop, and it was pretty straightforward to be able to do with Coiled notebooks. So with that, I will sort of wrap things up, summarize, turn it over for Q&A. So we're excited about Coiled notebooks. Hopefully this gave a good sense for what it's like to work with them. It's a pretty lightweight tool. It helps when analyzing cloud data or when you need some type of special hardware, whether it be just a bigger machine with more memory, more cores, or exotic hardware like GPUs. So yeah, with that, I'll say thank you all for joining. Really appreciate the time. If you don't already have a Coiled account and want to get started using Coiled notebooks, you can go to coiled.io/start to sign up for Coiled. I do want to mention it's free to get started with Coiled. Your first 10,000 CPU hours every month are free. Coiled does not charge you for managing those computations. So it's a lot of the computations we run are actually fit pretty comfortably within that free tier. So we also highly value user feedback. If you are able to try out Coiled notebooks, please let us know about your experience. You can go to the Coiled feedback repo and open an issue there to let us know what your experience was like. Or if you prefer, you can email support@coiled.io. With that, I'll just say thank you again and open it up for Q&A.
Thanks, James. We've got a couple questions in the Q&A so far. Pratyush is wondering how folks might be able to switch between GCP and AWS on Coiled. So sounds like you want to run some jobs on GCP and others on AWS.
Yeah, great question. So Coiled supports, I was running here on AWS. I just happened to be attached to an account on AWS. We also support GCP. So everything I just showed, you can do on both AWS and or on GCP. So great question.
Yeah, and then Jason Gilman is wondering, when you connect Coiled to your own AWS account, if you can deploy the Coiled web UI there.
Yeah, I'm not 100% sure about the question, so I'm going to hopefully answer it. If I'm not, please follow up with a follow-up question. Yeah, we run things inside of your AWS account, and the Coiled app I was showing here, we host that. So this is sort of the centralized app that everyone runs. Again, we don't actually have, the cloud account that this is attached to is your cloud account, but we are hosting the web UI.
Great. Thanks, James. We've got a question from Dimitro. Hi, James. Thanks for the demo. Dimitro is wondering if there is a section in the troubleshooting documentation specifically for running notebooks. Dimitro ran into some issues trying to run notebook instances and isn't quite sure about the best way to get help.
Gotcha. Thanks for trying out notebooks, and sorry to hear you ran into some issues. Yes, I would. You can open up an issue in the public Coiled feedback repo, or you can email support@coiled.io, and we will get back to you quickly with some support.
Great. And then, okay, great. Jason's got a follow-up question. Jason's wondering, how does the web UI know the status of the cluster running in your account?
Okay. So Coiled runs inside your cloud account. So you give Coiled permissions, some sort of minimal set of permissions to do things like spin up EC2 instances, pull Docker images, tear down EC2 instances. So we sort of are doing that on your behalf. So we are aware of what things we've spun up. We need to be aware of that so we know when to spin them down. So that's how Coiled is aware of the status of clusters.
Cool. So Pratyush has a follow-up question. It sounds like Pratyush started Coiled with AWS initially, I see, and is wondering if it's possible to have multiple accounts there.
Yes, it is possible. Yep, we can absolutely have a second account open for you. I'm assuming you started with AWS initially. You now want to have another account with GCP or something, for example. Yeah, that's great. If you want to send support@coiled.io email, we'll get that account open for
you. Cool. And Dimitro's wondering how to find out, the AWS IAM identity that's being used for the notebook.
Good question. I'm not sure I know that off the top of my head. I also realized I'm not sharing my screen anymore. Before I was like pointing at the screen. Apologies. We have in our documentation a list of all the permissions that are needed. So we can make sure to send you, I don't know if you have that link handy, Sarah, I can throw it in the chat.
Yep, I got it. It's not, Dimitro, to answer your question, it's not a different policy for notebooks than it is for Coiled more generally. So I've just dropped a link in the Q&A there, but that's that's in our docs. And feel free to reach out if you have more questions on those or how to tailor them to your needs.
If not, then yeah, again, thanks all for coming. Thanks for the great questions. Feel free to reach out if you have any additional follow-up questions later on, or if you have any feedback about Coiled notebooks. We really appreciate it.
Thanks everyone for joining. Thanks, James.